Hello everybody, this is the Pre-Med Companion with another high-yield topic on the biochemistry section of the MCAT. Here we're going to be discussing the titration curve of the amino acid alanine. Notice at a pH of less than 2, so like from 0 to about 2, it exists in this form where both the amino group and the carboxylic acid group are both protonated. So at a pKa of 1, something starts to happen. So this is the first buffer zone. So notice a buffer zone means that you have resistance to changes in pH. So even though we're adding a base, OH, it's only increasing the pH very slowly, and that's because we have a buffer zone. And at this first buffer zone, you have equal concentrations of this form and this form of alanine. So you'll notice that the amino group is still protonated because it's very basic. However, the carboxylic acid group, as you start to increase the OH concentration, it'll start acting as an acid, thus donating a hydrogen atom and becoming the deprotonated form. So at a pH less than 2, let me know in the comment section what the charge will be of the overall solution. And then for Pi, this is the isoelectric point. Notice how we don't have a buffer anymore, so we have a dramatic change in pH with only very little increase in the OH equivalents. And then the solution will only contain the protonated form of the amino group, and that's because still we're at a relatively low pH. However, the carboxylic acid group will all be deprotonated because relative to the pKa of the carboxylic acid, the pH is pretty high. All right, also let me know what the charge will be at this point. Moving on to pKa2, which is the second buffer zone. So you'll notice that again, this is like where we have that resistance to change. However, because we are increasing the pH enough, even though the amino group is technically a base, if you increase the pH enough, it'll start acting as an acid, thus donating one of its hydrogen atoms and becoming the deprotonated form. So at the second buffer zone, we'll have equal concentrations of this form and this form, where notice all of the carboxylic acid is deprotonated. However, in this one, the amino group is deprotonated. However, in the other one, the amino group is protonated. Also, let me know what the charge will be at this point in the comment section. If you found this video helpful, like and follow to see more of my content.